Assalamu alaikum. This is 11th chemistry, and our today's topic is ionic bond or electrovalent bond. Now, before starting this, let me give you a brief this account of this chemical bonding. As far as this chemical bonding is concerned, you know that, dear students, you know that these atoms, they are unstable. These are the neutral species, and they are unstable. Now every atom tends to attain stability. It tends to attain stability either by losing or by gaining of electrons, with the exception of these zero group elements which are present in group 18th of the periodic table. As these elements, they have got a stable configuration, or I would say that their outer electron octet is complete, is outermost this outermost shell, or their octet is complete, with the exception of this helium, which has got two electrons in it as a duplet. So these zero group elements, they are also called as noble gases. They are also, because as they have got stable configuration, so they do not take part in this chemical bonding. Now, as far as the other atoms are concerned, other groups of the periodic table, starting from first group to the 17th group, we see that the atoms do not have got their completely filled their octets or duplets. Now, so these atoms, they therefore take part in chemical bonding either by losing or by gaining electrons. Now, being unstable, these atoms, other than these noble gases, they don't have got the independent existence. So they form molecules through the formation of bonds, and in this way they lose energy, and thereby they attain the stability. Now, uh, now, uh, now, as far as the the bonds are concerned, we have got various types of bonds. We have got ionic bond, which is also known as this electrovalent bond. Then we have got covalent bond. Then we have got metallic bond, hydrogen bond, and these van der Waals, the forces of attraction. Now, as far as this bond is concerned, a bond, this bond, it we can define a chemical bond. It is an electrostatic force of attraction between the two atoms, which keeps them together in a molecule. So I would say that this chemical bond, it is an attractive force between the two atoms, which keeps them together in a molecule. Now, as far as this ionic bond is concerned, this type of bond, or it is also known as electrovalent bond, it is formed between two atoms, or between an electropositive atom and an electronegative atom, by transfer of one or more electrons. The electropositive atom, it loses an electron, it loses one or more electrons to form a positive ion, or it's also known as cation, and this electron is then gained by another atom, which is which we call as electronegative atom, and this gains this electron, it forms an anion. And the two oppositely charged ions, we have got this cation, which results from the electropositive atom, and then we have got the anion, which results from the electronegative atom. They approach each other, or they are attracted towards each other by means of an electrostatic force of attraction, and that electrostatic force of attraction gives rise to this ionic bond, or an electrovalent bond. Now, the atom here, we see that the atom which loses this electron, that is called the donor atom, and the other atom which accepts the electron, that is called as that is called the acceptor. Now, Now these two atoms, that is donor and acceptor, they approach each other through the formation of by means of this electrostatic force of attraction, and giving rise to the formation of this ionic bond. Now here I will give you an example. You just we take the example of sodium chloride. Now, as far as this sodium is concerned, it is present in group first, first A of a periodic table, and its atomic number is 11. Now, in sodium, we see that the configuration is 281. That means it has got a single electron in its outermost shell, or the outermost shell, that is also called as the valence shell. Then this sodium atom, now it needs 7 electrons to complete its octet, but the gaining of these select 7 electrons is not possible because it requires a large amount of energy. On the other hand, in case of chlorine, we see that the atomic number, it has got this atomic number is 17, and it has got 7 valence electrons in its outermost shell. Now these 7 electrons, which are 7 valence electrons, or they can easily take out this electron from the sodium atom, sodium atom, and to attain the configuration of the nearest noble gas, that is argon, in case of this chlorine. Whereas this sodium atom, after losing this electron, it attains the nearest zero, this noble gas configuration, that is neon, which has got a atomic number of 10, and with 8 electrons in its outermost shell. Now these go after losing this single electron, sodium atom, it changes into cation, that is Na positive monovalent, and we have got this chlorine atom. This picks up this electron, and it forms anion. Now these two anions, they are attracted towards each other by means of this bond, which is known as ionic bond. Now, after the formation of this ionic bond, we see the electronic configuration of this chloride ion. It is 288. Now, in case of sodium, which has lost 1 electron, it is now configuration becomes 28. That it resembles neon, while as this the configuration of this chloride ion, it now resembles this argon. Now, another example I will show here. We have got this calcium fluoride. Now calcium, now this is having it has got its atomic number of 20, and its electronic configuration is 288 and 2. Now as far as this electronic configuration is concerned, we see that there are two valence electrons in its outermost shell, or in its valence shell. Now on the other hand, in case of this fluorine atom, we see that its atomic number is 9, and it has got 7 valence electrons. Now since we have got 2 valence electrons in case of this calcium, this atom, so two these fluorine atoms are needed to pick up these 2 electrons. Now see here how one electron gets transferred to this fluorine atom, and another gets transferred to this. Now after losing these 2 electrons, this calcium, it forms a divalent cation, divalent positive cation. Now in this case, since two fluorine atoms are needed, so two fluoride ions are formed, and in this way, in this way we see that two bonds are formed, one between fluorine and calcium, and another between another fluorine atom and this calcium atom. So the formula becomes CF2. Again here we see this calcium, after losing these 2 electrons, it attains the noble gas configuration, that is of argon. And in case of this, we see this fluorine. Now after forming this fluoride ion, that is anion, or it attains a configuration of the neon. Now, as far as the factors which influence the formation of ionic bond are concerned, there are a number of factors. One of the factors is, that is ionization energy. Now as far as this ionization energy is concerned, ionization energy, we define it as like this: the amount of energy that is required to remove the most loosely bound electrons most loosely bound electrons from an isolated gaseous atom. So this we call as, it is known as the ionization enthalpy, or we also call it as ionization energy. Now, as far as, since the bond is formed between two atoms, electropositive and electronegative atom. Now, electropositive atom that loses this electron to form a cation. So lesser the ionization enthalpy of electropositive atom, greater will be the formation of cation, and more easily this ionic bond will be formed. Now, in case of periodic table, if we see, we have got the groups first A and second A, which are present in S block of the periodic table. They have got a low value of ionization enthalpy, so they readily give rise to the formation of these ionic bonds. Now, as far as this second factor is concerned, we are discussing the factors which influence the formation of this ionic bond. The second factor, we have got this electron gain enthalpy. Again, we see as the bond is formed between two atoms by transfer of electrons. And now one atom that loses the electron, which is called as electropositive atom, and the other atom which gains this electron, that is called as electronegative atom. So electron gain enthalpy we can define as the energy released when an isolated gaseous atom takes up an electron to form anion. So that is for electronegative atom. Now, since the electron lost by the electropositive atom is gained by electronegative atom, so greater the value of negative electron gain enthalpy, easier will be the formation of anion. So easier will be the formation of anion, and we see greater will be the formation of ionic bond. Now in periodic table, as we know that this in case the elements which are present in the group 17th, they are known as the halogens. They have got maximum tendency to form anions. The elements of group 17th of periodic tables, since they have got 7 electrons in their octet, so they have got maximum tendency to form anions, because they have got very high negative electron gain enthalpy. Now, as far as the sixth group of the periodic table is concerned, which have got they have got 6 valence electrons, which in their outermost shell, that is in case of these oxygen family. Now they have their negative electron gain enthalpy is slightly less than that of the halogens, that is 17th group of the periodic table, because here we see and this energy is needed to form anions divalent anions. Then another factor, we have got this lattice energy or lattice enthalpy. Now lattice since these or lattice enthalpy, the ionic, as we know that these ionic compounds, they exist as crystalline solids, and this type of arrangement we call as, it is known as crystal lattice. Since these oppositely charged ions, which take part in the formation of these ionic bonds, so when they approach each other, energy is released. When these oppositely charged ions, that is cations and anions, they are attracted towards each other, and this energy which is lost as a result of attraction between these two oppositely charged ions, this is known as the lattice energy, or we can also define it like this: it is the energy released of an when 1 mole of a crystalline solid is formed by the combination of oppositely charged ions. Now, so greater the magnitude of this lattice energy, since this lattice energy is just given out, so greater its magnitude, or greater the magnitude of the lattice energy, greater will be the stability of the ionic bond, or the ionic bond would be, in other words, we would say that ionic bond formed will be stronger. Now, as far as this lattice energy is concerned, this lattice energy, it depends upon the size of the ion, and it also depends upon the charge on the ions. Now, as far as the size of the ions is concerned, the size of the this ions, it plays a very important role. It has got a significant influence over this lattice energy. Smaller the size of the ions, lesser will be the internuclear distance, and once the internuclear distance is less, greater will be the magnitude of this lattice energy. As far as the second factor is concerned, and that is the charge on the ions. Now, greater the magnitude of charge on these ions, higher will be the greater will be the interionic attractions, and greater will be the value of this lattice energy, or maximum will be the magnitude of this lattice energy. So these are the factors which have got their influence in the formation of these ionic bonds. Now, as far as the properties of these ionic compounds are concerned, we will discuss it in the next topic. This is for today. Okay, thank you very much.